this lesson video, we discuss paver productions and apply that in problem 2. When we maintain the efficient production, we need to have operations that are continuous. And when it continuous, we mean that the production at the asphalt cement plant and the paver on site have to be balanced. And when we want to be balanced, the two critical choke points that we need to consider is the loading of the whole unit at the plant and the link between the whole unit and the paver. And with that, go back to the slide that I present in the first lesson video of this lesson. The two that I want to mention that here, the whole unit loaded at the plant and the link between the whole unit and the paver on the road when we pave. So those two play a critical role in ensuring a continuous paving operation. And when it continuous paving operation, we need to determine the number of trucks. It means the whole unit that be balanced, and in that case the number of trucks have to be equal to the ratio of the plant productions over the truck production. So with that, let's apply to problem 2 in here. The asphalt plant can produce 224 tons per hour, so that is basically plant productions. A project requires paving individual 12 length and with 2-inch lift averages, and with the unit weight is 112 pounds per square yard in. So why the unit here a little bit strange in construction compared to typical engineering class. Square yard in, it measured by the surface is square yard, and then inch for the lift of the pavement in inch. So that's why the volume square yard inch measured by volume, 2 dimension in yard, and the thickness measured in inch. What average paver speed will match the plant production? So there are 2 questions here. What the average paver speed that match plant production, and how many 20 ton of bottom dump truck will be required if the total whole cycle time is 55 minutes. So from that one, I draw a road in here, so 3 miles, and they paving each lane individually. So each lane is 12 feet, and the thickness for the lift, it means the asphalt thickness is 2 inches. So the 2 questions I already mentioned, and then we need to find out the average paver speed and the number of trucks, dump truck required. And with that, maybe we find out the number of dump trucks first, because we can be able to easy to find out the plant production, which is already given to 324 tons per hour, and we can find out the truck production and apply that ratio to get the balanced number of trucks. So let's do that one. So the first thing first, we need to find the truck production. And truck productions, as you can see, for one trucks have 2 tons. So the basically production is the volume per cycle, the general equation, if you recall, volume per cycle time number of cycle per hour, number of, so let's make here cycle per hour, and then of course we time the efficiency. If they given factor, so that typical truck production, and then we can apply in here It equal to volume per cycle, that is 20 ton. 20 ton per truck. That is one cycle that can read that. Number of cycle per hours, the cycle time is 55 minutes. So we can have the 60 minutes per hour divided by the cycle time, 55 minutes per cycle. And then time efficiency factor, they don't mention it, so it will be 1. So from that, we can make it equal to 21.8 ton per hour per truck, for one truck. And now we can use that equation, number of trucks, then we can determine the number of trucks or whole unit. And from the number of trucks, we have plant production over truck production, so it equal to plant production over truck production. That's the equation. So plug in plant production 324 ton per hour divided by truck production 21.8 ton per hour per truck. So you see ton per hour cancel out, truck kick up, so that is the number of trucks. The unit it will be, so it's about 15 trucks. So that we can determine the first answer, number of trucks. And now the second is average speed. To determine the average speed, and we need to know the volume of the pavement. And typically we can determine that in per linear foot of the lane. So let's put it 1 linear foot of the lane. Then what is the volume? What is the volume of 1 linear foot here? That is something we want to first to find out. 1 foot. So with that we can determine the volume. In, and like I say, they use a square yard in for volume, so we have to say square yard inch, so that is the volume per foot of pavement length, paving length, and that equal to volume equal to 3 sides. So we have the first one is the thickness. The question gives us 2 inch, 2 inch thick, time 12, each lane 12 feet, that is wide. And for we only consider 1 linear foot, so it will be 1 foot length, that is length. And of course the unit in this case will be inch, feet, so it will be square feet inch in the answer, but we want square yard inch, so we have to unit conversion. So with feet inch already in the one unit we want to determine, we need to convert square feet to square yard, so it will be 9, 3 times 3 square feet per square yard. So from that we can determine that equal to 266 square yard inch over foot of paving length. And that's not enough, because the equation, we need to find out the ton, the unit production here, ton in here. So we need to do that conversion. And they give us for the asphalt 112 pound per square yard inch. So that is the density basically. So we can plug in that, we can determine the weight of asphalt per foot of paving length. So it will be 2.66 square yard inch over foot of length time the density 112 square yard pound per square yard pound per square yard inch that they give us in the problem. And of course, because the unit we use in the production here is ton, so we do the unit conversion, and 2,000 pound per ton. So we have unit conversion 2,000 pound per ton. So that unit, then the answer should be 0.149 ton per linear foot of the paving length, per linear foot of paving length. And now the speed to for one linear foot of the paving length, it use 0.149 ton. Now for 1 hour, the production of the plant is 324 ton per hour. So what should be speed that can consume that volume? So as you can see from that, we can see the average paver speed, so that we have a balance or continuous paving productions. Whatever the plant produce, it can be used on site continuously. So from that we can have what? We have the production in here for the whatever it produce on in the plant, 324 ton per hour. So that is the plant can produce. And for 1 linear foot we of the paving length, we use 0.149 ton per feet. So from that we can get equal to 2,174.5 ton cancel out, ton cancel out. So we get feet per hour. So it will be feet per hour. So that is the speed. But normally feet, then we use either mile per hour or feet per minute. So we just change that to feet per minute or mile per hour. So let's change feet to minutes. So we get 2174.5. And of course you divide by the feet per hour, and then we time 1 for the unit conversion, 1 hour for 60 minutes to make it the unit make sense. And that we can get the average speed equal to 36.2 feet per minute. And that is the second answer we need to determine, and that done for paper production and application to problem 2.